more cases soon. Integrating from -1 to 1. Weight now is this function. Weight now is this function, and then fg. So this is famous case called Chebyshev case. So the previous one and this one has this big difference, right? This big difference. So I will handle this case and use Gram-Schmidt process to find about 3 functions, not 4. So with this, first function is 1. Second function is x plus a1, right? So x plus a1, then psi 2, psi 1 should be equal to 0. Then it is integral from -1 to 1, 1 over 1 minus x squared, and then psi 2 x plus a1, and then psi 1, 1 dx. Then this is an odd function gone, right? And then a1 times some integral. Then some integral value times a1 is equal to something. So this gives us a1 is 0. So it's x. Do you follow me? So next case is psi 2, psi 3, right? Psi 3 is nothing but x squared plus a1 times 1, and then a2 times x, right? This is psi 3. Then psi 3, 0 equals psi 3, psi 1, then it is equal to -1 to 1, 1 over square root of 1 minus x squared, and then psi 3, x squared plus a1 plus a2x multiplied by psi 1, that is 1 dx. Then if we integrate, then this integral, and then a1 times, so it's time to use MATLAB. Last time I did hand calculation, but this time I want to use MATLAB to do the calculation. So let's do the calculation of this first integral. So integrate this function from integrate x squared over square root of 1 minus x squared from -1 to 1. This will give us pi 1/2 times pi, right? Is pi above or below? Right? This is pi over 2. So first integral, this integral is pi over 2. The second integral is this one, right? Pi. And then this integral is odd, 0, right? So we have found this relation. So from this, a1 is what? A1 is -1/2, right? A1 is -1/2. So A1 is -1/2. Let's calculate A2 by doing the next integral. Next integral is integrating this -1 to 1, 1 over square root of x squared, and then x squared minus 1/2 plus a2x, and then multiply by x dx. Then first integral is odd, gone. Second integral is odd, gone. Third integral is a3 times some integral, so equals 0. So because of this, no matter what value is here, a3 is what? 0. So a3 is 0, gone. So we have found psi 3. Do you follow me or not? Eight is 0. Oh, sorry. 8 is 0. Thank you. Right? 8 is 0. So if you don't follow me, you cannot solve the problems assigned. Problems assigned has different weight, different boundary, not necessarily -1, different bound. For instance, we can change this problem from 0 to 1. Then the whole result varies, right? So this is the situation. Then we have found 3 functions. 1, x squared minus 1/2. These are the cases that we can obtain. And if you have a question up to this point, ask me. So psi 1 to 3, or you can use zero-based. But in MATLAB, zero-based index system isn't great, right? When I create these things, the math department used Maple. Maple uses zero-based index and any number-based index. So there was no trouble. But more and more people use MATLAB. So zero-based index isn't great. So I'm translating it to one-based index. So my summary has 0, 1, 2, but you can convert these things to 1 to 2. Now the next thing is finding P1, right? How can you find P1? Divide it by its norm, right? Divide it by its norm. Then how can you find the norm of 1? It is this. Norm of 1 is integrating the function 1 minus x squared, right? 1 minus x squared, and then multiply by 1, 1, right? Multiply by 1, 1, 1, x minus 1 to 1. So, oh, sorry. Pi, right? Pi is the result of this. So pi is the result of the calculation. So we should take a square root. So this is the orthonormal basis. If you don't understand, ask me. So I did the inner product, right? I did the inner product to determine the norm. Norm squared happened to be pi. So norm should be square root of pi. I divide the function by its norm to create unit norm. Do you completely follow me, or you are lost? Then the next thing is x. So I will convert it. I will change it to, instead of 1, 1, I will change it to xx, right? X multiplied by x, or x squared might be easier, right? X squared. Then it is 2, 1/2 times pi, right? Pi. So this norm is pi over 2 with square root, right? So phi2 is nothing but 2 over pi multiplied by x. This is it. And then third one, I can change this to the next basis function, that is x squared minus 1/2. Then it gives us pi over 8. So this gives us square root of pi over 8. Then P3 equals this reciprocal 8 over pi, or 2 times 2 over pi times x squared minus 1/2. Or you can multiply 2 inside, right? If you multiply 2 inside, then it is square root of 2 over pi 2x squared minus 1. So all these were straightforward calculations. If you completely understand this, and I will cover the last example. We are covering minus a to a situation, but now I want to cover 0 to something situation. In other words, you cannot just remove terms. So let's do it. Laguerre found the next case, and the inner product looks like this. So in short, Laguerre found this thing. Weight is e to the power of negative x. Interval is from 0 to infinity. But you should be very careful. Homework has some pattern like this, and I used 0 to a, 0 to 1, or 0 to something instead of 0 to infinity. So different story. You should not just say, oh, Laguerre polynomial. No, it's not like that. Depending on interval, it completely changes, right? So after this, I intentionally change this to 0 to 1. After this, what happens? It is FG inner product is anywhere from 0 to infinity, and then this weight function, and then FG multiplication, dx. Then, after this, we get this result. First of all, psi 1 is 1, psi 2 is x plus a1, right? Then, let's determine a1 by using the inner product. So, psi 2, psi 1 is 0. This is integral from 0 to infinity, e to the minus x, and then f is x plus a1, and then g is 1 dx. Then, we cannot have odd even situation. We should really integrate everything. So, term by term, I will do. So, term by term. So, integral from exponential function of minus x, right? Multiplied by x, integrate from, what is the infinity? INF? INF? So 1, right? First integral is 1, right? If you integrate this first term, it is 1. And then if you integrate the second term, it is 1. Right? 1 times a1. So, because of this, a1 is what? Minus 1. So, it is x minus 1. Do you follow me? Or not? The next one is psi 2. Psi 2 is x squared plus a1 times 1 plus a2 times x minus 1, right? This is psi 2. Psi 3, thank you. Then, by the definition, psi 3, psi 1 should be equal to 0. And this gives us 0 to infinity e to the power of minus x. And then x squared plus a1 plus a2 x minus 1 multiplied by 1 dx. Then let's do the integral of individual term. First integral is exponential function of x squared. That should be equal to 2. The first integral is 2. Second integral is a1 multiplied by this one, right? This one is 1. And then the next integral is a2 multiplied by x minus 1 multiplied by this one, right? X minus 1. Then it is equal to 0. Great. 0. And then we already know it is negative 1, right? We already know it is negative 1. So from this, a2 should be equal to what? Just a moment. Just a moment. This a1 has nothing to do with the previous a1. So I should not. Sorry. This a1 has nothing to do with the previous a1, right? Previous a1. Oh, I see. Yeah, I somehow touched this thing, right? I should have touched. Sorry. With this thing, right? So a2 is 0 already. I mean, a2 itself is not 0. A2 contribution is 0, right? Yeah. So A1 is negative 2. Do you follow me? Right? A2 multiplied by 0. So A2 has no contribution. So A1 plus this one is 0. So A1 is negative. I was a little confused because of the above one, right? Above one. Now with this, we use the second case. 0 equals P is 3 psi 2, and then 0 to infinity, e to the power of negative x squared minus 2 plus a2 x minus 1 multiplied by second function x dx. Is it x or x minus 1, right? X minus 1. So this is what we encountered. Now, let's do the integral. So first part is this portion. I will indicate the first part. We should multiply this thing, and this thing. This is the first part, right? I can even include this thing together. So first part include this thing, and this whole thing, and this thing. And second include this thing, this whole thing, and then this thing. So I will do the integral twice. So exponential function, x squared minus 2, and then multiply by x minus 1, right? So I am doing this portion. Then this equals 4. This equals 4. So with MATLAB, it isn't very bad. So after doing this first portion is 4, and then A2 multiplied the second portion. Second portion is x squared, and then x minus 1, and then x minus 1, right? This should be done, and it is equal to 1. So from this, A2 is what? Negative 4, right? A2 is negative 4. So we have found everything. So let's summarize. Psi 3 equals x squared minus 2 plus negative 4, x minus 1. Then let's simplify. X squared minus 4x plus 4 minus 2 plus 2, right? Done. So I have determined psi 1, psi 2, psi 3, and we can continue. With MATLAB, it's way easier. So if you don't have a question, I will find the norm of psi 1, psi 2, psi 3 to determine P1, P2, P3. Any questions? Then let's calculate the norm. All abstract, right? All abstract. First of all, let's summarize. Psi 1 is 1. Psi 2, Psi 1 is 1. Psi 2 is x minus 1. Psi 3 is x squared minus 4x plus 2. Now it's time to determine psi 1 norm squared. Psi 1 norm squared will be determined. Then what should we do? Use inner product definition. It is this one, and then 1 squared, right? 1 squared. Do you follow me? 1 squared. Then it gives us a little bit bigger. It gives us 1, right? Result is 1. So its square root is 1. So it is just this one, right? From this, P1 is 1. 1 over 1. Any questions? The next thing is psi 2. So I will change this to x minus 1. And it is 1. So psi 2 is also this one. The next thing is psi 3. Psi 3 is replacing it by x, the 4 x squared minus 4x, 4 times x, plus 2. Then 4, right? 4 is the so it is 2, right? So you divide by 2. So you can determine P1, P2, P3. Now, intentionally, I will change the interval so that you can be familiar with general setting, not special setting like this. But I will pause, and you may browse the note and check your answer. So intentionally, I will change the inner product. So interval is not from 0 to infinity anymore. I will change the interval from 0 to 1. Suddenly, everything should change. Because of this change, suddenly everything should change. So I will find psi 0, psi 1, psi 2, and so on. Maybe 2 functions at least. So psi 1 is 1. Psi 2 is x plus a1 times this one, right? So this is psi 2. Then, now, inner product is what? The interval is from 0 to 1, and then e to the power of negative x, f, g. This is the inner product, right? This is the inner product. Everything is the same but the boundary. Because of this boundary change, everything should change. You cannot just copy Laguerre polynomial and then say the answer is like, no, completely wrong. So let's do it. Psi 2, psi 1 calculation. This is 0 to 1, e to the power of negative x, and then x plus a1, and then multiply by 1 dx. Then, as you can see, we should do actual integration. So first one is integral of this thing from of times x from 0 to 1 instead of 0 to infinity. Then it gives us this value. Take a look. It's different, right? This value is different. So the first part is different. 1 minus e over 2, right? So this is the integral of this part. The second part is a1 multiplied the integral of this thing. So if you integrate this thing without x, then it is 1 minus 1 over e. 1 minus 1 over e. And then this should be equal to 0, right? This whole thing should be equal to 0 because of orthogonality. Because of this, a1 is what? a1 equals 1 minus 1 minus, I will just keep it this way with minus. So because of this, it is minus 1 minus 2 over e, 1 minus 1 over e. If I multiply top and bottom by e, then it is minus e minus 2, e minus 1. So this is a1. So we can see the difference. Just boundary change caused the function change. So I saw some students submit homework just by using the famous cases. No, boundary has changed. It's not from minus 1 to 1. It is from 0. Let's look at the actual problem set. Now, when you do homework, you should understand these things completely. So you should use computer package such as, like software package such as MATLAB to do the integral, but you should understand what is going on, not just copying. So as you can see here, the problem is this 1, but boundary is different, not from negative 1 to 1. Do you follow me? Because of this, it's not Alexander anymore. Take a look. Negative x is similar, but it's not from 0 to infinity. It's from 0 to 1. Do you follow me? Because of this change, your functions are not the same as the one that we used. Do you follow me? So you should do these things, right? So you should find total 3 functions in each case, right? You should find 3 functions. So I found 1 and this one. So 1 more function will be enough. Do you want me to find? Just a moment. This is the same as the homework, so I cannot continue. But if you want me to do it with different one than homework, then I can do. So I will save and then go to the next page. So do you want me to do something different than the homework? Then I can find 3 functions. You may pick W and the interval. What W do you want? Anything is okay. E to the x instead of negative x, right? And then interval, -1 to 0, -1 to 1, right? So I changed both so that you cannot imitate. Thank you. So let's do it. Then 1, right? Psi 1 is 1. Psi 2 is x plus a1. Psi 2, psi 1, product should be 0, inner product. And then because of this, -1 to 1, e to the x instead of negative x. And then x plus a1. And then 1 should be equal to 0. It's not even or odd anymore because of this function, right? Because of this, it's not even or odd anymore. Just a function. So only way is using MATLAB. Of course, if you have enough time, you can do the hand calculation, but I don't encourage hand calculation. So this is it. Oh, -1 to 1, right? Because of this calculation, -1 to 1 gives us e to the 2 over e. So this gives us 2 over e. First integral is done. Second integral is a1 times what? Exponential function integral. Then it is e minus 1 over e. This is the result, right? E minus 1 over e. So what is a1? a1 equals this over negative of this one, right? So a1 equals minus e over 2 over e over e minus 1/2. I mean this one. So this is the result. I don't want to have e everywhere, or over e everywhere, so I will multiply e, then it is -2 over e squared minus 1, right? So this is better. This is better expression than the previous one because I don't want to have over e every. So with this, I can write the function. The function is x minus 2 over e squared minus 1. So psi 2 is found. Now psi 3. A little bit tough, right? You can expect, right? Tough. Computer algebra system is nice. When I learned these things, I don't even have terminal. So I should use punch card and then submit it and then wait about 2 or 3 days. And it depends with syntax error, all sorts of error. So it's better to do hand calculation at that time. I did hand calculation instead of relying on computer. So psi 2 is found. It is x minus 2 over e squared minus 1. Psi 3 will be found. Psi 3 is x squared plus a1 times 1, and then a2 times this one, x minus 2 over e squared. This is the reason why I wanted to show you. I want to show you what kind of things you should do to solve homework problems. So let's do the integral then. Psi 3 inner product psi 1 should be 0. This gives us the integral from -1 to 1 e to the x multiplied by psi 3 x squared plus a1 plus a2 x minus 2 over e squared minus 1 multiplied by 1 dx, right? The next one will have x, right? There are two cases. I will write this case and then imitate this case. So the first integral is x squared. I think I did the first integral. X squared multiplied by exponential function, integrate. Oh, did I do correctly? I might did everything wrong because I found that the boundaries are not minus 1 to 1. Oh, it is a different story. I found that boundaries are not from minus 1. So this might be wrong. Sorry for my mistake. I used MATLAB with boundary 0 to 1. So these values could be wrong. So I will correct these things and then continue. Because without correct values here, we cannot expect correct things. Sorry for my mistake. So it's from this function from negative 1 to 1, not 0 to 1. So this is the correct result. So e minus 5 over e is the result. Sorry. E minus 5 over e is the result. And then a1 times this thing. Oh, sorry. Even this is a mistake. What I'm doing? What am I doing? Take a look. X times this one. So I should finish early today. Is correct then? What is wrong? So this is correct. E 2 over E. I should have enough space or my brain is dead today. I couldn't sleep well. That was the reason. So everything was correct. The next thing is integrating this exponential function itself. I think I did it correct. I was scared somehow, right? I was scared because I made so many mistakes. I was scared. Up to this point, it's okay. So let's continue. X squared. Then it is this one, sure. So x squared is now found, right? X squared is found from negative 1 to 1. Then it is e minus 5 over e. So the first term is e minus 5 over e. And then a1 multiplied by some result, exponential function. I guess that is done already, e minus. But if you don't think so, please confirm. Please let me know, right? And then finally, this thing should be typed. Exponential function and then multiply by x minus 2 over exponential value of 1 squared minus 1. So this should be done. What happened? Oh, oh I hate it. Oh, thank you. I see. Very small. Almost 0, right? Very small. Very small. I'm relieved. I hope this is not a mistake. Because of this, a1 equals minus e minus 5 over e, and then e minus 1 over e. Or you can multiply e, then minus e squared minus 5 over e squared minus 1, right? So this is a1. Now the second integral can be done. And we can determine everything. But before the decision, we replace this by minus e squared minus 5 over e squared minus 1. Then finally, side 3, side 2. Wow, this will be tough. Minus 1 to 1, e to the x. And then x squared, and then tough thing, e squared minus 5 over e squared minus 1. And then a2 times x minus 2 over e squared minus 1. And then multiply by side 2. Side 2 is x minus, I do not know. So what is side 2? It is here, right? This is side x minus. Right? So this is tougher integral. If you do if you use hand calculation, it will be very tough. Let me do this kind of very straightforward. So you may use approximation instead of exact calculation from this point on. In any case, let's do the integral. So x squared minus exponential value of 1 squared minus 5 over exponential value of 1 squared minus 1. And then multiply by the right side, x minus 2 times this one, right? So I wrote the first part. Could be wrong. Should be correct. This should be correct. X squared. Do you find the mistake? Right? This is missing. So 0.744 can be used, right? 0.744 can be. 0.1744. You follow me? So I did the first integral. Now I will extract A2 and do the second integral. And then do the second integral. So second integral contains exponential function. And then instead of this thing, x minus 2 over this thing. And then the right side is the same, right? This is the case. It is 0.6486. So 0.6486. So this should be equal to 0. Do you follow me? Then because of this, A2 equals roughly negative 0.1744 divided by 0.6486. So let's do it. So 0.3719. So this is it. So we have found A2. We have found A2. So even for A1, you can use approximate value. So psi 3 equals x squared, and then instead of using exact value, I will calculate it. Point 3739. A2 is what? Really? Why did I do that? I should quit early today. Sorry for all mistakes. 0.2689. So I should not make many mistakes. 0.689. And then this should be 0.689. And then x minus this value, this value, 2 over this will be approximated. 2 over exponential value of 1 squared minus 1 will be approximated. 0.313. Done, right? So we have found the psi 3 function. Let's simplify. I don't trust my hand calculation, so I will let do. So it is, but why did it do it? So first to do it, and then double the answer, right? What is the problem? Oh, I see. So what should I do? Then I will do the hand calculation. It's better to do hand calculation than 0.2689x, and then the only thing remaining is straightforward calculation with numbers, right? So it is just this number. This number, subtract by this number, multiply by this number, right? So 0.2897. So done. So we have found P2, psi 1, psi 2, psi 3 in approximation. Exact thing may be tougher. So let's write the result. With these things, we can write psi 1 is 1, psi 2 is x minus 0.3130, and then psi 3 is x squared minus 0.2689x minus 0.2897. Done, right? So we have found these things. But the next thing is tougher one. It is also normal basis. Then what should we do? You should divide this thing by its norm, right? That's it. So psi 1 norm squared will be calculated. This will be calculated. Then it is the integral from negative 1 to 1, e to the x. And then multiply by 1 and then 1. Do you follow me? So this should be psi 1 value. I want approximation, not the exact calculation. So we go all the way up to exponential function with 1, 1, right? 1 squared. Then it gives us this one, double this thing with answer. Then it is 2.3504. Take a look and then check. Do you follow me? So if we do square root, then square root, then square root, then square root will be done. It is 1.5331. Done, right? Then this should divide it. In other words, P1 equals 1 over 1.5331. And if we do this approximation, 6523. Any questions about the first function? So this function is the function that we can use. Then let's check whether it really has norm close to 1, right? This function should have norm close to 1. So let's check. So norm calculation is done by plugging in something, right? It is 0.6523. Right? Do you follow me? This will give us the norm of this integral. So let's do it. Oh, close to 1, right? So I have found the first function, psi 1, phi of 1, because it gives us the norm close to 1. Let's do the other calculation. But do you want more calculation, or this is enough? Because this is not even homework. Just be made up, right? So we don't have to spend too much time. I'm just giving you the idea of the approach that you should take. But if you need more calculation, I can do it. But there is no point of doing this thing over and over. Do you want me or not? Then, final portion. For the three famous cases, we have a different way of generating polynomials. Instead of using Gram-Schmidt process, people did investigation and then found this kind of method. Oh, we need to create psi 0 function, psi 1 function, and so on. Psi 1 function, psi 2 function, and so on. Instead of creating this way, we can use the formula, right? We can use the formula. So we can create P0 function representing psi 1, P1 function representing P2, and then P2 function represents psi 3. So we can create the right side not by Gram-Schmidt process, but by some formula. So the formula is provided, and the formula is this. A little bit strange, but it is this. 2 to the power of n multiplied by n factorial multiplied by x squared minus 1 to the power of n differentiated n times. This is not power, differentiated n times. So this is the formula that you can use. It's called the Rodriguez formula. So Rodriguez developed this formula, and using this formula, we can find the Zandra polynomial, the psi function. So do you see the difference between this one and Gram-Schmidt process? We used Gram-Schmidt process to determine psi 1 and then psi 2 and then psi 3 and so on. It is tough. But now we are not using Gram-Schmidt process. We are using formula to determine it. Then let's determine the formula. First of all, psi 0 is by definition 1, right? That determines this psi 1, right? Now, you now see the reason why I used zero-based index in previous lectures, in the lectures that I used for 5 years, because it exactly matches. Now, P1, let's find P1. Then we should use 1 everywhere. Then 1 over 2 to the power of 1, 1 factorial, and then x squared minus 1 to the power of 1. Differentiated how many times? 1 time. Then it is 1/2 multiplied by this derivative. This derivative is what? 2x. Then x is 1. So you should see the difference between the previous approach and this approach. Previous approach relied on Gram-Schmidt process. This approach relies on formula. But if you don't understand, ask me. So next thing, P2. P2 is what? P2 is with 2, right? 2, and then 2 factorial. Do you follow me? 2 here, and then x squared minus 1 squared, and then second derivative. So let's multiply this out. If we multiply this out, then x to the 4th minus 2x squared plus 1, and then second derivative. Right? So if we do the second derivative thing, then it is 4x cubed minus 4x plus 0. And one more time, 12x squared minus 4. Right? So if we write it, P2 equals, if we do this, then 1 over 8, then 12x squared minus 4. If we divide both sides by 4, then it is 2, and then 3x squared minus 1, right, P2. So we have found this thing. So we can use formula to determine these things. We, in fact, found psi 4, meaning P3. So let's calculate it. P3 is 2 to the power of 3 factorial, and then this thing cubed, right? X squared minus 1 cubed to the power of differentiate 3 times. So let's do the inner product. If we do this thing, then it is x to the 6th power minus 3 times x to the 4th power plus 3 times x to the 2nd power, and then minus 1, right? I did the cube thing, right? I did the cube thing. I cubed this thing to get this thing. Then let's differentiate this first time. Then it is 6x to the 5th minus 12x to the 3rd plus 6x minus 0. And let's differentiate. Then this is the second time, right? If we differentiate this, then it is 30x to the 4th minus 36x squared plus 6. If I differentiate one more time, then it is 120x to the 3rd, and then 72x, right? 72x. Then if we extract 120, then it is x cubed minus 72 over 120 x. 72 over 120 can be simplified. 24 is the common factor. 24 is the common factor. Then upstairs has 3, downstairs 5, right? So it is, I'm cornered, right? So 120 x cubed minus 3/5 x. Do you recognize this function? We used Gram-Schmidt process to determine this part, right? So this number and this number I can't guess them. So we can find the orthogonal basis of the famous case by using formula, not by Gram-Schmidt process. Then the next thing is this. How can you find orthonormal basis? The answer is yes. The only thing that you should multiply in front of this piece is multiplying. I will use the next. So the Pn, assume that Pn is found, then this is orthogonal basis. It's not orthonormal yet. Then how can you make orthonormal? The only thing that you need to multiply is this one. You multiply 2n plus 1 over 2 in the square root. Then it's orthonormal. So once orthogonal function is found, then you can easily determine it. So this is the theory developed. Then what about other cases? Other cases also have similar thing. For instance, Chebyshev case. Chebyshev case, then we can use this function. So we use this cosine of n cosine theta. Oh, sorry. Cosine of n theta, not cosine, sorry. Cosine of n theta, where theta is represented by this thing. So cosine n theta represents t sub n, and then this t sub n replaces, so this t sub n replaces psi 1. So psi 1 is t0, psi 2 is t1, psi 3 is t2, and so on, right? So we can generate psi 1, psi 2, psi 3 not by Gram-Schmidt process, but by the formula t0, t1, t2. And then we can also find the orthonormal basis by multiplying something that I wrote on the summary. Any questions or comments? Then how can you calculate cosine and theta if you know cosine theta? That is the next thing. So I will explain it. Take a look. Cosine and theta can be calculated. So I will do this Euler notation. E to the power of I n theta equals cosine n theta times plus I times sine n theta. Then take a look. E to the power of I theta to the power of n gives us e cosine theta plus I sine theta to the power of n. Do you follow me or not? So there are two different ways of calculating e to the power of I n theta, top way or bottom way. Then what should we do? The real part of this thing, the real part of this thing is what? Cosine n theta. Right? The real part of the above thing is cosine n theta. Now look at this. It's complex. Then real part of this cosine theta plus I sine theta to the power of n is the result, right? This is the result. So this way we can calculate. So for instance, we want to calculate cosine 1 theta, right? We want to calculate cosine 1 theta. Then cosine theta plus I sine theta to the power of 1, right? Power of 1. And then what is the real part? What is the real part of this thing? Cosine theta, right? So cosine theta is cosine theta, and cosine theta is known to be x, right? This is that. Now, we are not interested in one case, but two cases. Cosine 2 theta. Cosine 2 theta equals real part of, right? Real part of cosine theta plus sine theta squared. So if we square it, then cosine squared theta, right? Plus 2I sine theta cosine theta, and then minus sine squared theta. Sine squared theta is what? Sine squared theta is what? 1 minus cosine squared theta. So sine theta can be always converted to 1 minus cosine squared theta. Then the real part is just this thing. Then it is 2 cosine squared theta minus 1. This graph. So I extract the real part. Imaginary part is dumped. If we extract the real part, then it's cosine squared theta minus sine squared theta is rewritten, and it's this one. Because cosine theta is x, it is what? 2x squared minus 1. Any questions? Then the next thing is cubed, right? Cosine 3 theta is equal to cosine theta plus I sine theta cubed, and then real part, right? Real part. So let's cube this thing. Then it is cosine cubed theta plus 3 times cosine squared theta I sine theta plus 3 times cosine theta I sine theta squared, and then finally I sine theta cubed. So I cubed this thing. And as you can see, cosine cubed theta has real part, right? So this term has real part. This term has imaginary part. This term will have real part. This term has imaginary part. Only two things are necessary. So the real part is cosine cubed theta plus 3 times cosine theta, and then this squared is minus sine squared theta. So minus sine squared theta can be converted to what? Cosine squared theta minus 1, right? Because sine squared theta is 1 minus cosine squared, we can convert it. Because of this conversion, this is cosine cubed theta plus 3 cosine theta, and then cosine squared theta minus 1. Then we can replace cosine theta by x. I will go above. I will go to the second column, third column. I will pause before going to the third column. So please check and then ask. Then, because of this, I will use the right side. X cubed minus 3x, x squared minus 1. Then, I use this plus, right? 4x cubed minus 3x, right? 4x cubed minus 3x is the result. So you can continue these things to find polynomials. So this is Chebyshev approach. So you can do the fourth power also, and then find the real part, and then use cosine theta. By replacing cosine theta by x, you can find the polynomial. So this is Chebyshev approach instead of using Gram-Schmidt class. Any questions? Then finally, Laguerre polynomial also has the generating function. So Laguerre polynomial has a generating function called ln. Ln is looks a little bit strange. N factorial e to the power of minus x, and then differentiating x to the power of n e to the power of minus x n times, differentiating this n times. This is Laguerre polynomial, and the relation is similar. Psi 1 can be generated by L0. Psi 1 can be generated by, 2 can be generated by L1 and so on, right? So 1 off. Then we can create L0 by doing what? 0. 0 factorial by definition is 1. And then x to the power of 0 is 1. E to the power of negative x. Differentiate 0 times. We don't differentiate. Then e to the x, e to the minus cancel each other out, then it is 1. Right? It is the same as psi 1. The next thing is L1. I will not go to the next case because we don't have enough time, but after L1, I will stop. 1 factorial e to the power of negative x, and then x to the power of 1, x to the power of 1, and then e to the power of negative x. And then differentiate it 1 time. If we differentiate this, we should use the product rule. So e to the negative x here, but product rule says 1 e to the x, and then differentiate this, then x times e to the minus x, and then minus 1, right? Minus 1 multiplied, I mean. Then if we divide by e to the negative x, then it is 1 plus x with negative 1. Then it is 1 minus x. So this is the psi 2. We can continue to find this. Then finally, should we use this formula to solve the problem? There is a better one. There is a better one than this one. That one is the last thing, and then I will stop. So instead of using this thing, I will show you the formula and then continue. So instead of using these things, we can use better thing. The better thing is the recursion. What happened? So the better thing is this relation, recursive relation. So for instance, to find P2, you can use P1 and P0. To find P2, you can use P1 and P0. To find P3, use P2 and P1. So once you create P0 and P1, then after P0 and P1, you can use P0 and P1 to determine P2, P3, P4, and so on. Especially program, you can program it and use very fast. The same thing happens here. Instead of doing my thing, like powering and then extracting real part, imaginary part, you determine P2 by using P1 and P0. L is the same. Instead of calculating L, we use L1 and L0 to determine L2 and so on. But L has specific definition. It's not just size thing. L has a definition you use. So let's use these things to determine. So I will extract this part. So I will extract this part and then copy. Copy the result, right? I will use this result. So let's do it. First of all, we should know what P0 and P1 is. So P0 is, did we calculate P0? And what is P1? X, right? We now have a starting. So you should at least use formula to calculate starting thing. Then what is P2? P2 equals, with 2, it is 3 over 2, and then x times P1 x minus 2 minus 1 over, right? and then P0, 1. Do you follow me? I calculate P2. But if you don't understand, ask. Let's calculate P3, but simplify P2 and then calculate P3. So this is simplified then. 3x squared minus 1, and then 1/2. So I simplified. So by using this thing, we can calculate P3, P4, P5, and so on. So in my opinion, you get the point, right? But if you didn't get the point, ask me. So let's stop here. And if you didn't get the point, approach and ask. For other functions, it's possible. Yes? T also, what is T0? T0 is 1, right? And then T1 is x, right? Right? We obtained these things using formula. T0 is 1. Then, what is T2? T2 equals 2x times x minus 1. So 2x squared minus 1 is T2. And you can calculate T2 and 3. So you can calculate 10 functions like this very fast. Instead of Gram-Schmidt process or formula, you can use recursion to do this calculation fast. So you can ask any questions. If you completely understand, you may leave the room.